Hey class, today we're going to go over one of the first sections in our current chapter that we're going to be starting and taking a test on called Chemical Quantities. And this section is titled The Mole and Avogadro's Number. Most of my chemistry classes usually end on this chapter and we do pretty well on it. I will start Advanced Chem on this chapter again because this builds the basis of everything we do on here on out. So, as a reminder from general chemistry, recall that matter is composed of atoms, molecules, formula units, and ions. And chemists use a unit that is a specified number of particles. This unit is called the mole, and it's defined as containing 6.02 times 10 to the 23rd representative particles of any substance. And it's actually the SI unit for measuring the amount of substance that something has. And this number, this 6.02 times 10 to the 23rd, is called Avogadro's number. Now, when I use the term representative particles on the last slide, that refers to several different things. It refers to elements being known as atoms. Molecular compounds are known as molecules, and hopefully you remember from our general chemistry review, molecular compounds are going to be nonmetals and metalloids. There are no metals at all in here. Ions, of course, are named after ions. These are things with a charge. So, for example, if you have a calcium 2 plus ion or an SO4 2 negative ion by itself, those are charges. And the last one is formula unit, and these talk about ionic compounds. And these are things that contain a metal bonded with a nonmetal. So the dead key giveaway for ionic compounds is this metal aspect. Now the relationship 1 mole equals 6.02 times 10 to the 23rd is the basis for conversion factors that we're going to be using to convert between moles and representative particles. So depending on what you're trying to cancel, you can use 1 mole over Avogadro's number or Avogadro's number over 1 mole. Please note down below, again, representative particle can mean several different things. For example, copper is an element, so it's known as an atom. Nitrogen gas, this is one of our diatomic molecules, so that's a molecule. Diatomic means that it's bonded to itself, so there's two elements together, that's a molecule. Water is all nonmetals, so it's a molecule. Calcium, it says it's an ion, see this charge here. And then calcium fluoride, calcium's a metal, which makes that a formula unit. All of those, 1 mole is always going to be equal to that Avogadro's number. Now let's get into doing some converting now that we refreshed ourselves on it. It says magnesium is a light metal used in the manufacture of aircraft, automobile wheels, and tools. How many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? First thing that you should recognize is that this says atoms of magnesium, and that makes sense. Atoms go with an element, and magnesium is the element abbreviated Mg. So when you do conversions, you always start with what you're given. So here I'm given 1.25 times 10 to the 23rd atoms of Mg. And then we want to set up the conversion factor. So we want to be able to cancel atoms, and so we have to put it on the bottom here. And then we're trying to get to moles, so it's going to go on top. Now remember, the number that's always attached to moles is 1. And here, atoms is going to be the 6.02 times 10 to the 23rd that we just previously learned. Now we just throw it in our calculator. Again, if the number's on top, we multiply. If it's on bottom, we divide. We are working with scientific notation, so please remember to use parentheses. So we can take 1.25 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, put those in parentheses. And when you do that, you get 0.207641196. Now we are working with scientific notation, so when we do scientific notation, we're going to look with what we measured in the problem. Our conversion factor does not count. And here we have 3 sig figs, so my answer should only go to 3. So 0.20, and that 6 rounds up that 7 to an 8. Also, I need my unit, so this is moles of what? Of magnesium. Moles of magnesium. Here, I want you guys to pause this video and you guys try to do this problem on your own. When you're done, you guys can unpause it and see how you did. Hopefully, you guys got the following answer. Note that molecules and molecules go across from each other to cancel. The reason this is molecules is because CO2 are both nonmetals. This is a molecular compound. Again, we're rounding to 3 sig figs because here I have 3 sig figs. Now we're going to try going backwards, and our question is, how many formula units are in 1.45 moles of Na2S? If we look at this, Na2S does match up with formula units because sodium is a metal. With any conversion, we're going to always start with what we're given. So we are given the 1.45 moles, and that's moles of Na2S. And now we're going to try to cancel it. Here, remember, moles is what we need to cancel, and it's got to go diagonal. We're trying to get to formula units, and so yes, you can still abbreviate them FU. And then we have to fill in our numbers. The number 1 will always go with mole, and then here my formula unit will be my 6.02 times 10 to the 23rd. Notice my numbers on top now, so I'm going to be multiplying. Don't forget to put your scientific notation in parentheses. When you solve for this, you get 8.729 times 10 to the 23rd. But I can only have 3 sig figs here, so you get 8.73 times 10 to the 23rd. Your unit would be formula units of what? Of sodium sulfide. Now I want you guys to try to calculate these on your own. Pause the video and then see if you're right on the next slide. So here's the answer. How did you guys do? Again, remember, it makes sense here. We have atoms and iron is an element, so those two go together. Your moles need to cancel, and rounding to 3 sig figs. Now, where people get tripped up last year was, what if we are asked to find atoms in compounds? Because we know atoms go with elements. When we're finding atoms in a compound, we have to go one extra step. So to do this, we have to know how many atoms are in the chemical formula of the compound. So to find the number of atoms in a given number of moles of a compound, you first determine the number of representative particles first. So the first conversion you should always do is by multiplying the number of moles by 6.02 times 10 to the 23rd over 1 mole. Then what you need to do is multiply that by the number of atoms in each molecule or formula unit based on the chemical formula. So for example, if the chemical formula was H2O, that's going to be 3 atoms. 2 from the hydrogen and 1 from the oxygen. In fact, let's kind of look at an example to give us a better idea. Here it says propane is a gas used for cooking and heating. How many atoms are in 2.12 moles of propane? First thing you should know is that this is not a single element by itself, so it can't go with atoms. This is actually a molecular compound, so it's a molecule. That's because carbon and hydrogen are both nonmetals. So we know we'll have that extra step. We always start with what we're given, 2.12 moles of C3H8. And I need to cancel moles, so I'm going to go on the bottom. And a lot of people want to put atoms up here, but we're working with C3H8, and that is a molecule. So note 1 always goes with moles, and then this is going to be Avogadro's number. And we've canceled out moles, but we're left with molecule. That's not what we wanted. We wanted atoms. That tells us, yes, do one more step. So for every one molecule of C3H8, we have to find out how many atoms are in it. And that's going to be 3 carbon plus 3 hydrogen. So 3 plus 8 is going to give me 11. 11 atoms total. So my moles cancel, my molecules cancel, and I have 11. Now these are all on the top, so you guys can multiply it across. Again, don't forget to use your parentheses. When you do that, you should get 1.403864 times 10 to the 25th. But here I only need 3 sig figs, so 1.40 times 10 to the 25th. My unit would be atoms in what compound? There are that many atoms in propane. So now I want you to kind of pause the video and see how you guys do on this one. When you unpause, let's see if you get it correct. So you should have the following work on here and get the following answer. Again, this one's asking how many atoms, but water is not an element. Water is a molecule because it's a molecular compound. So here I have to take that extra step, and there are actually 2 plus 1 option, 3 atoms for that. So we round to 3 sig figs and say atoms in H2O. And here is the last example that we're going to work through. What if it's asking for specific atoms instead of total atoms? Our example here is how many chlorine atoms are in 3.48 moles of magnesium chloride. Same steps that we're going to do before, but instead of counting all the atoms, we're only going to look at chlorine. We're always going to begin with what we know, 3.48 moles of MgCl2. And then in order to cancel moles, it has to go on the bottom. But if I'm looking at this compound, it's not a single element. Also, it's not a molecule because we have a metal here. So whenever we have that metal, remember those are formula units. So 1 mole, always 1, and then 6.02 times 10 to the 23rd formula units. We've canceled out our moles, so now we got to cancel out our formula unit. For every one of these, we have to count how many chlorine atoms. So I'm specifically looking at chlorine here, and there are 2 chlorine atoms. When you actually multiply that across, you get 4.18992 times 10 to the 24th. Here I have 3 sig figs, so I need 3 down here, 4.19 times 10 to the 24th. And don't forget your label, chlorine atoms in magnesium chloride. Here's the last example for you guys to try on your own. You guys can pause this video and then unpause it to see what the answer is on the next slide. Okay, so here's the answer. Notice here that it's asking for atoms, but this is a compound. It's actually a molecular compound, which is why we named it molecules here. Since it specifically asked for carbon, we only put 6 carbon. And then don't forget we're rounding to 3 sig figs, so 2.48 times 10 to the 25th carbon atoms in C6H6. Let's write that again so people can see it a little bit more clearly. C6H6. And that's the end of today's lesson. If you have any questions, please make sure you contact me, and I hope you guys have a great day.